Hello, welcome to another session in sets. Today I'll be covering worded problems in sets. Alright, so what are some assumptions to this? There are some general results that we need to know before we get into this. Alright, so the general results that we will be making use of a lot in these problems are number of elements of A union B is equal to number of elements of A plus the number of elements of B minus the number of elements of A intersect B. Secondly, the next general result is the number of elements of the union system is equal to the number of elements of A union B plus the number of elements of A union B complement. So A union B and A union B complement. Right? What exists inside of A union B and what does not exist inside of A union B. Alright, so let's get into a work example involving this. Alright, so for my work example, I'm considering this problem. A survey was conducted in a sporting club. There were 37 members in that club who responded to the survey. So it took a survey about the sports that they played. In that club, there were persons who played volleyball and hockey. The results of that survey revealed that 18 persons played volleyball and 15 persons played hockey. There were also some members who played both hockey and volleyball, and that number is X. There were also 3 X members who did not play volleyball and hockey. So you have some members who did not participate in hockey or volleyball. Alright, so part A, you're required to draw a Venn diagram to illustrate the results of this survey. Part B, how many members played both volleyball and hockey. Part C, how many members played volleyball only mean it as the only sport, and how many played hockey only, right, as the only sport, as the only sport of recreation. Part D, how many members did not play volleyball and hockey. Alright, so let's get to the Venn diagram. Alright, so producing a Venn diagram, we have the universal set here, that is rectangle, to be denoted by the letter U. Alright, we know that there are some. We started by saying let A represent persons who are playing volleyball and let B represent persons playing hockey. So here is set A and here is set B. Now we know that we have persons who are playing both volleyball and hockey. This is the region X. This represents the intersection of A and B. A intersect B, this region here. Alright, we know that 18 persons play volleyball. If 18 persons play volleyball, then this region here represents E only. Alright, and this will be 18 subtract X, 18 minus X. Alright, so now this whole set, the number of persons playing volleyball, A is 18 persons. Alright, that's why 18 to the X. Alright, the number of persons playing hockey is 50. This represents all the persons playing hockey. Alright, but out of those persons who are playing hockey, there are some who also play volleyball. So that's why we say 50 subtract X, 50 minus X. So this region here represents the number of persons playing hockey only. Now, there are 3X persons who do not play hockey or volleyball. This represents the region that's on the outside of volleyball and hockey. So these persons play some other sport besides volleyball and hockey. Alright, so we have to examine the rules of the problem. Alright, so let's try to put on this here in set language. Alright, in the problem we are told the number of persons that play hockey only, the number of persons that play hockey is 18. Right, number of persons that play hockey are 18. Alright, and number of persons that play the number of persons that play volleyball is 18. The number of persons that play hockey is 15. Alright, and the intersection here, that is the number of persons that play both volleyball and hockey, is X. And the number of persons that do not play volleyball or hockey is 3X. And 37 persons responding in the survey, so this represents the universal set. Alright, so a set equation that can help us here is this equation here. Number of elements of A union B is equal to number of elements of A plus the number of elements of B minus the number of elements of A intersect B. Alright, so how do we go about figuring out which one is which? We know that n of A is 80, so that comes here. Alright, n of B is 50, so that comes there. N of A intersect B is x, so that comes across here. Alright. Alright, so question is how many elements do we have in A union B? That is the question. Alright, now we can get his answer from the example and the Venn diagram. Alright, so the number of elements in the universal set is 37. This represented 37 persons who responded to the survey. Alright, now in that survey, there were 3x persons who could not play volleyball or hockey. Alright, so how many persons in A union B? Well, this here is this here is 37 minus 3x. 37 minus 3x will give us how many persons exist inside of here in A union B. Alright, so this region here, A union B, can be summed up as 37 minus 3x. Alright, so now our elements of A union B is really 37 minus 3x. Alright, as we explained from before. Here's 18, here's 15, and here's x. Now we're going to rearrange this to solve for x. Alright, so 18 plus 15 is 33. 37 comes here, minus 3x minus x. Put all the x's on one side, put all the number terms on the other side. So 37 comes here, 33 comes there, minus 3x, you put it on the right hand side, so the sign will change. So you get 3x minus x, that's 2x. 37 minus 33 is 4, so your x is equal to 4 divided by 2. Therefore, we can conclude from this that two persons played both volleyball and hockey. Alright, so let us recap. Alright, so we have a survey being done at Sporting Club. 37 members responded to the survey. We have a person who played volleyball and hockey. 18 persons played volleyball, 15 persons played hockey. Number of persons that play in both is X. There are 3X members who did not play volleyball and hockey. They engage in different sporting activities. Part A, the Venn diagram. Did this already. This was covered just now. How many members play both volleyball and hockey? This worked out to be 2. X worked out to be 2. Alright, part C. How many members play volleyball only? And how many play hockey only? And in part D, how many members did not play volleyball and hockey? So that's it. Alright, so the number of persons that play volleyball only is really 18 minus x. Alright, now you're seeing this from the Venn diagram. Alright, so the number of persons that play hockey only will be this region here. Alright, that is persons who played hockey as the only sport. So you see that this is 18 minus x. Alright, the number of persons that played, this here is volleyball. The number of persons that played volleyball only is 18 minus x. Alright, correction. Here is volleyball. Alright, number of persons that played volleyball is 18 minus x. This represents volleyball only. Alright, the number of persons that played hockey only is this region here. Alright, you see that? 15 minus x. This represents this region. Alright, so the number of persons that played volleyball only is 18 minus x. The number of persons that played hockey only is 15 minus x. Alright, so you need to keep this in mind when you move on to part C and part D. Alright, and 3x represents the persons who are not playing volleyball or hockey. So alright, so the number of persons that plays volleyball only is 18 minus x. We found that we determined that x was 2. So it's 18 minus 2, so 16 persons play volleyball as their only sport. The number of persons that play hockey only is 15 minus x. X is 2, so that's 15 subtract 2, which gives 13. So 13 persons played hockey only. Alright? Part B, the number of persons who did not play either volleyball or hockey. Alright? And that was represented by X. That was represented by 3X. Alright? 3X represented that number. Alright? So we already have the value of X, so it's already 3 times 2. 3 times 2 is really 6. So therefore 6 persons did not play volleyball or hockey. Alright, so just to recap, what was the formula? Alright, so the general formula we used to solve this problem was this here. Number of elements of A union B is equal to number of elements of A plus number of elements of B. Subtract the number of elements of A intersect B and the number of elements in the universal set. The number of elements of A union B plus the number of elements of A union B complement. Alright, so this is what is inside of A and B, and this is what is not inside of A and B. Alright, this would have been our 3x. Alright, this would have been our 3x. Okay, and this of U would be 57. Alright, so I hope you learned something today. Alright, and hope you learned something today, and thanks for listening.